Today we're looking at the working memory model. This is the model that replaced the idea that short-term memory is just one single store. Before we begin, just a reminder that there's note-making scaffolding and a self-marking revision activity linked below. The working memory model, developed by Baddeley and Hitch in 1974, changed how psychologists think about short-term memory. Instead of seeing short-term memory as one single box that just holds information, they argued that it's actually an active system. In other words, when you're using your memory in real life, such as thinking, reading, calculating, or problem solving, your memory is doing something, not just storing information. Working memory allows us to store and process information at the same time. For example, when you do mental maths, you have to hold numbers in your head while also manipulating them. And when you read, you remember earlier parts of the sentence while trying to understand what comes next. When you follow instructions, you keep each step in mind while carrying it out. And in problem solving, you hold information while working towards a solution. So memory here isn't just storage, it's part of thinking itself. Baddeley and Hitch proposed that working memory is made up of 4 separate components, each with a different role: the central executive, the phonological loop, the visuo-spatial sketchpad, and the episodic buffer. These systems work together, but each one is specialized for a different type of information. The central executive is the control system. You can think of it as the manager of working memory. It directs attention, allocates mental resources, switches between tasks, and decides which subsystem should deal with a particular task. One really important point for exams: the central executive does not store information. It only controls and coordinates. However, it has a very limited processing capacity, which means that if you try to do too many demanding things at once, it becomes overloaded. That's why multitasking often doesn't work as well as we think it does. The phonological loop deals with verbal and auditory information, things we hear and things we say. And this includes words, numbers, and spoken instructions. It has 2 parts. First, the phonological store, often called the inner ear, and this holds sounds of words that you hear. Second, the articulatory process, known as the inner voice, and this is the part that silently repeats information in your head. So, if you've ever repeated a phone number to yourself so you don't forget it, that's the phonological loop in action. The phonological loop has a very limited capacity. It can only hold what you say in about 2 seconds. To keep information active, we use maintenance rehearsal, which simply means repeating it silently. This also explains the word length effect. Short words are remembered better than long words because they can be rehearsed more quickly and within that 2-second time limit. So it's not about how many items you remember, it's about how long they take to say. Now let's look at the visuo-spatial sketchpad, or VSS. The visuo-spatial sketchpad deals with visual images, space, and movement. It helps you to picture shapes, remember routes, and imagine where objects are in space. For example, if you're trying to picture your classroom layout or mentally follow directions on a map, you're using your visuo-spatial sketchpad. Its capacity is limited to around 3 or 4 objects at a time, and it has 2 parts: the visual cache, which stores what things look like, color, shape, and the inner scribe, which deals with position and movement, where things are and how they move. Now we're going to look at the episodic buffer. The episodic buffer was added later by Baddeley in the year 2000. This system acts as a temporary storage space that integrates information from the phonological loop, the visuo-spatial sketchpad, and long-term memory. It combines different types of information into a single, meaningful episode, hence the term episodic. So, for example, when you remember a short story you've just heard, including the words, the images, and what it all means, that integration is happening in the episodic buffer. Importantly, it also provides the link between working memory and long-term memory. So, to summarize, the central executive controls attention, the phonological loop deals with sounds and words, the visuo-spatial sketchpad handles images and space, and the episodic buffer integrates information and links working memory to long-term memory. And together these systems explain how short-term memory actively works. Now let's look at strengths and limitations. First of all, one major strength of the model comes from dual task studies. Baddeley and Hitch in 1976 found that people can perform two tasks at the same time more easily when the tasks use different components of working memory. For example, a visual task and a verbal task can be done together fairly well. But two visual tasks at the same time interfere with each other. And this supports the idea that working memory is made up of separate subsystems that can operate independently. Another strength comes from clinical evidence. Studies of brain-damaged patients show selective impairment. Some patients have damage that affects verbal memory but leaves visual memory intact, or the other way round. And this strongly suggests that different parts of working memory can be damaged independently, supporting the idea that short-term memory is not a single store. And then we have something called the word length effect. The word length effect also supports the model. Short words are recalled better than long words because they can be rehearsed within the phonological loop's 2-second capacity. And this provides experimental evidence for limited capacity and the role of maintenance rehearsal in the phonological loop. Now let's look at a couple of limitations. First of all, the central executive. One key limitation of the model is the central executive. Baddeley himself described it as the most important but least understood component. We know what it does in general. That's controlling attention and coordinating tasks. But we don't fully understand how it works. Some psychologists argue that it may actually be more than one system rather than a single process. Because it's poorly defined, this reduces the scientific precision of the model. Another limitation is that much of the supporting evidence comes from laboratory experiments, and these often involve artificial tasks that may not reflect how memory is used in everyday life. As a result, the research may lack ecological validity, meaning the findings might not always generalize to real-world situations. To conclude, overall, the working memory model is a major improvement on earlier models because it explains how short-term memory actually works. And it's strongly supported by dual task studies, clinical evidence, and the word length effect. But it's weakened by the vague nature of the central executive and the artificial nature of some supporting research. So, in conclusion, the model gives us a powerful explanation of working memory, but it would benefit from a clearer understanding of how the central executive really operates.